Hello everyone, I'm Cho, and today I'm going to present my project on Big Data Analytics class, which is EduLink, a semantic linking of study area network. So let's get started with the motivation behind this work. So um, when you study something or come up with some class or some concepts, educational concepts, sometimes you may realize that it has a lot of things that connect together. For example, maybe the term social studies may connect to other several terms like economics, psychology, or even the data science, but you may wonder how it connects to each other. So maybe you can feel like, it disconnect together, disconnect from each other, but in reality, some part of it has an insight that connected together. So we need some tools that might show the can like connectivity between this term. So the knowledge is a network. It's not just a list. So as I mentioned, we need some tools that can represent or show the connection between the knowledge together. So nowadays currently we have a something called link data or open link data. So in this work we use DBpedia as a data source for represent the relationship, but the challenge is offer this kind of relation but it's hidden. So we need some tools and some work to make it has an insight, to extract some insight from these data sources. So let me introducing about the semantic web technology, which is a core technology that we use in this project. So we use RDF. So RDF is a framework that represent knowledge as a triple form, including subject, predicate, object. Like so, and we have a SparkQL. SparkQL is like a query language. Seems like the SQL that we use, but in this case we use with graph data uh, specify on the RDF. And in this work we use DBpedia, which is a structured version of the Wikipedia, which contain the RDF here. So we're gonna use the SparkQL to query the data from DBpedia. And why it matters? So once we query the data from DBpedia, it contains a meaningful relationship between the academic concepts. So we can use to build the interactive application here. So our objective here gonna be three main things. First, we're gonna extract and visualize semantic relationships between the study area. So in this work, we use SparkQL and RDF Graph. And of course, we are like query the graph, right? So we're gonna integrate the knowledge that we learned from this class about the pruning strategy to make it even faster. And the last part, we're gonna develop the interactive web application. So we're gonna use the pruning strategy from this part to enhance the efficiency of our web application. So our web application gonna be the application that can discover the network of the study area. Like if you wonder social study, or which area study gonna connect with the social study, you can use this tool to discover this kind of network. And moving on to the methodology. So this work we have three main part or layer here. So the first layer we're gonna do about the formal design. We're gonna declare about the strategy to do a query, and also about the semantic web technology. We're gonna declare the script or technique for query. So we're gonna elaborate more about this part further. And second part, we're gonna uh, run the experiment on these query strategies to measure about the performance, and then we're gonna select the high potential strategy to apply with the application layer here. So about the study network, we query from, as I mentioned, we are querying from the OpenLink data. So once we query here, we're gonna do some process part, and then we do serialize to be our own study network here. So our study network consists three part here. The first one is the core part, which is a study areas. It may consist mostly it consists about the concept or study area. For example, the class calculus, social study, biology, mathematics, something on this line. And the second part is gonna be the education domains. It can be like person, it can be a place like university or school. And the last part is going to be the enrichment part, which is consists of the link information further from the previous two part to make it even more like has a enriched information for impine or inference later. And about the query pipeline, we have it three main part here. First one is about the pre-processing. We're going to declare the query script, and then we're gonna query using the SparkQL wrapper. So it's gonna send the request through the HTTP protocol here to query the data from the DBpedia here. Once we query here, we're gonna receive in form of the RDF here, and then we do the post processing to convert the data to use with our application here. So this is the examples of the SparkQL, how we come up with this SparkQL. So we need to declare the sample statement here, like, oh, every entities in the network should be or must be the study area. So we need to look up for the ontology tag for this. So I discovered that in DBpedia, they has this tag for describe about the study concept. So I'm gonna integrate with a design the SparkQL script to query the data here. For example, I query all of the subject that have a hypernym to study. So we're gonna receive the entities that related to the study area. And this is the formal design for the query methods. I designed 4 method for query. So the first one is about the query, the baseline. The baseline that we use is about the union one. So the union one is like we declare the condition here, and then we just combine the condition part here, and then we query. So it's gonna be the base line for it's gonna be the baseline for our experiment. And our second is about the value filtering. So we filter once we declare the variable here. So it's going to be different from the first part. We filter once we declare the variable, and then we query. And the third part, it is about the subquery pruning. So we do the subquery before we do the core query here. So it's going to be like define the scope of query. So maybe in some term or some textbooks is called early pruning. And the last part is the filter in union. Like in this part, we use a filter in on the we declare the dynamic sets here, and then we use a filter in to make it like distinguished, and then we query it. And talking about the size of the DBpedia is about 9.5 billion triples, and this rate we query approximately around 2 million triples to use to curate the study area network here. And this is the experimental result. After we run the experiment, we discovered that the technique that show the best performance is the subquery pruning, which is reducing execution time up to approximately 54% compared to the baseline, as you can see here. And also I run the experiment on the centrality measure to discover some insight about um, inside the term in the network here. I discovered that the result shows that the physiology and anthropology and sociology like dominate all of the metrics here. And once we enrich more data, the result is changed as well. So after we enrich more about the term of the schools or person, maybe it's make a it's very effect on the centrality, but on the page rank, which is we are scope only on the wiki link, is not affect that much. And the last part is about the application layer. So the application layer, we use a Steamlit here as a main framework for execute the application layer. And this is the excerpt or the sample of the application. We can input the area that we interested, and we can query the graph of the link concepts that related to the concept that we interested to. For example, the calculus maybe is interest is linked to the like discrete mathematics, analytic geometry, or maybe the pure mathematics here. Also, we can adjust the layout of the graph visualization. We can visualize as a graph or as a tree. And we are moving to the demo of the project here. All right, now we are in the application layer here. So the first thing that we can do here is query the information from the DBpedia. It's so this application is pretty simple here, and in addition, the highlight part of this work is we can query the graph of the information that related to the study area that we interested to. For example, I interested to calculus. I can calculate. I can query the calculus here, and we can even adjust the graph layout mode to tree to maybe it make more look easier to look. And we can toggle the info panel to look up for the information. For example, I interested about demography. I can click it on that, and it's going to query the information of the specific concept here, or even the larger term like the social studies here, as you can see. We can discover that social study is related to linked to the psychology, sociology, or even the philosophy here. And if we is look messy here, we can adjust the layout mode to tree to prevent the secret on the graph, so we can it's easier to see the hierarchical structure of the graph. Like social study is linked to history, and history is also linked to the physical history. So if we wonder what is that, we can figure out from the information panel here. So we can add the configuration. We can configure on the maximum depth here for even more depth of the graph. Right now we have a depth of 2, and we can also change the maximum of the total node here as well to prevent the overload or the over massive theater here, and this is the overall of the project. Thank you very much.